What's up, guys? I want to show you an example of something that it uses a lot of code you've seen before. We're going to do ifs and expressions and return and all the quarter one stuff we learned, but it's also going to add a new part and just put it together in a slightly nicer way. This is going to be a Tic Tac Toe game. There's nothing special about that. We could have used other examples, but I think it's going to work. So what I'm going to start with is not perfectly doing it line 1, line 2, 3, 4, 5 all the way down. I want to really stress to you guys that you don't have to just magically get it right on the first try. What you want to do is list the key stuff and then start filling it in. Doesn't have to be in order, doesn't have to be right. You just get a little bit at a time. Okay, so I'm going to hit enter because I always want to leave space above where I am. That's not necessary, it's just kind of nice. And I'm going to say, what do we need to do in a game of tic-tac-toe? Okay, if you're on paper, the first thing you got to do is draw the board. And you only have to do it once per game, but it is important, obviously. We can draw some horizontal lines and some vertical lines. On a computer, it's going to be different, but we're going to draw the board. And then you're going to have some other stuff that happens more than once. Like when somebody takes a turn, they're going to pick a spot and fill in the spot and check to see if they win. And all that is going to happen multiple times. So that's going to be what we're going to call a loop. So I'm going to indent it. I don't even know yet. Are we going to make it a for loop, a while loop? We'll see how it goes. But there are going to be some things that happen every turn. I think one of them is just going to be showing the board. We're just going to say, hey, what's our current status? What's filled in? What's not? Let's take a look. And then we're going to do, we're going to get the players move. We're going to say, hey, what spot do you want? And then we need to test whether it's good. If they say, I want the top left, but the top left is already filled in, we got to tell them right away, hey, that's no good. Try again before we move on. So we got to do this right away. But if it is good, if they choose a spot that's open and they fill it in, we probably want to test whether it's a win. We want to see if they get 3 in a row. And if so, it's done. We're kicked out of the loop. Game over. But if not, let's say they pick a spot, it was empty, they fill it in, but they don't win. We're just going to get ready for the next turn. So what do we need to do to get ready for the next turn? Well, I think we probably want to check to see if the board is full, okay? We could have done that at the beginning of the turn, but we didn't. So let's test whether the board is full. Because if it is, we can't do another turn. We're just going to tell them game over, the board is full, you know? So we might rearrange these later. We might add stuff, but we'll see how it goes. And then the final thing you need to do is switch the player. We got to, if this was on paper, you'd hand them the pen, or if this was on whiteboard, you'd hand them the marker or something. You got to switch from X to O and get ready for the next one. Because remember, all this stuff, all this code we're going to write applies to both. I'm not going to make a function to get the X move and then make another one to get the O move. I'm going to do one that works for both. So we're going to switch and then go through this same stuff. I'm not going to test whether X wins and then test whether O wins. I'm going to do it all in one versatile, generalized code, you know? So I just use the word function. So let's make some functions. In this one, it's probably going to be a function. And this one, you know, we'll give them names. We'll fill in the stuff. We'll see how it goes. I'm going to say, before that, though, we got to make the board. We got to make the board. And those are going to fill it in, but we got to start with something. I'm going to use these little brackets here when you make in Python a list. Okay, a list is a wonderful thing that you can fill with strings or integers or objects of a type you create or other lists or anything you want. And once they're there, you can change them, add to them, all kinds of stuff. So lists are really nice. And we could add this stuff right away. We could say like, add whatever you want. But you can also add it later. And the deal is, for this one, I'm going to make 9 blanks, right? For the Tic Tac Toe board, you need 9 blanks, and they're going to change when the players put X's and O's. And I decided I'm going to make it like an underscore, you know, but I hate typing this. I don't want to type, you know, like switching underscore and then hop over the quotation mark that they filled in. It's like, this is killing me. So I want to make the computer fill it in because I don't want to do that. So I'm going to say for I in range 9, because we need 9, we're going to go board.append. Append is a method of the board or the list that you can add stuff. And we're going to add this guy 9 times. Okay. So to test what that means, we're going to go print board, and it's going to give us 9 blanks. Now it doesn't look good. It doesn't look like a tic-tac-toe board, which would be 3 and then 3 in the middle and then 3 on the bottom, but it's 9 spots, and we'll make it pretty later. Okay. In fact, that's what the show board is going to be, right? We'll fill in some stuff there to do it. But that's a start. So let's say every turn some things are going to happen. Let's do the show board. Why not? I told you we don't have to go in order, and I'm kind of going in order, but we'll jump around later. Show board. Let's make a function called show board. What the heck? And then this is going to get called whenever we need to display our current status. It's giving me a red line. You know why? It's because the indenting is just something I made up. There's no reason yet, so we're going to tell it, hey, there's going to be a loop. All right, this stuff's going to happen until it's kicked out whenever somebody wins or the game is over. So that's our start. We might even change what kind of loop it is. We might make it for or while something else, but we'll give it a start. So show board, what are we going to do for that? We're going to want to print our first 3 and then our middle and then our bottom. So we're going to have like 3 lines, and we're going to go board, then a little number after it. Okay. Whenever you put whenever you want to talk about a certain spot on a list, like, oh, I want to get the 5th one or something, you put the little number after it in brackets, and that's called the index. The index means like which, you know, order it's in. So if I put 0, it's the first one, 1 is this next one, 2 is the next one. And for this, I don't want to use any fancy stuff. I want to just say 0, 1, 2. Okay. Boop. And that would print the top 3. Oh, and it's doing it infinitely because the while true. I'm going to put a break in there, and then I'm going to cut it later. But whenever I want to test something, I want to test it just once for now. So let's say, I know this is not beautiful. We'll make it nice later. But we want to get something that works. I'm going to go 0, 1, 2, and then 3, 4, 5, and then 6, 7, 8. Okay. We can do this with for loops and other cool stuff at another time. So this prints the board. This is 9 spots, currently blank. They're going to turn into X's and O's soon. And whenever we need to show the board, we can just say, hey, show board, and it'll run this. We don't have to copy these lines again because that would be really ugly. They're already really ugly. So let's say get the player's move and test whether it's good. We want to do these both at the same time because if it's not good, we got to tell them right away. We don't want to wait until later and go back. So I'm going to keep those two together. Let's say there's going to be a function called get player move. Yeah, why not? And we don't know what's going to be in there, but something's going to be in there. I'm going to say the word pass. Pass is what you do when you want to leave it blank for now, but you want to tell the computer. I just run through that. We'll fill it in later. Don't give me an error or anything. Test whether it's a win. Let's say I'm going to call that check for win. I'm going to go def check for when, and then again, we'll fill it in later. And then same thing for this guy. We're gonna say check for full. That sounds weird, but we can change our minds. Now, this is kind of just an upgraded version of what we started with. When you start with comments, the little hashtag and gray text, that's planning out what you're going to do, and you fill it in later. And this, by making the functions, it's just the same thing, right? It's just planning out what we're going to do and fill it in later. But it's another step in the right direction. And it's almost like if you do these tiny little layers, by the time you're done, it's done. It's like you almost never do. It feels like sometimes you almost never do the real code. You just wrap it in layers and layers of stuff, and then by the end you go, oh, hey, it's there. I didn't feel like I did anything at all. Sort of like in math, if you have this big problem, but you break it down into smaller and smaller steps, and each step is just like one tiny bit of algebra that takes you 4 seconds, and then you realize you've done it all. Now, I want to do this last little guy right here. I don't need to make a function for that because it's going to be so simple and it's going to be so easy. Switch player, that means if it's X, we're going to make it O, and if it's O, we're going to make it X. So let's say if player equals X. I know I haven't made the player variable yet, but we'll figure that out. Let's do that. And then else player equals X. Okay, so if it was X, it turns into O, otherwise it turns into X. We're going to have to make the player, and I'm going to do that outside the loop because it just has to be created once. Both for technical reasons, you have to make the variable exist in order to reference it later, but also for logical reasons, you have to have something to start with before you do the switching stuff. Okay. So now, let's do one of these other guys. What we're going to do is every turn, we're going to show the board, ask them to pick one, and they might say, oh, the bottom right, and then that'll turn into an X. And then see if they won or see if it's full, and if not, we'll show it again. Oh, fills in one, etc. Now, I don't want to keep going in order, and I want to show you that you can bounce around. You can do the easy stuff first. And I'll tell you that this one is going to be really easy. Check for full, because we just need to say, hey, is there a blank anywhere? If so, it's not full, right? And that is pretty doable. We can say for each spot on the board, if we ever see a blank, we're done. It's not full. Kicked us out of this function, okay? So I'm going to use the word spot, but that's not a real word. I just made that up. For spot in board, if spot is underscore, which is our blank, then return false, meaning, nope, it's not full. Okay. But if we don't, if that doesn't happen, we're going to say return true. So like if it goes through and finds the whole thing has no blanks, then it's finally true, but that's not going to happen very often, right? Maybe never. If your players are good, somebody's going to win, I think. I don't know. So that is pretty easy, and these other ones are going to take a little bit more thought. It's fine to do the easy ones first, and if I realize that this was wrong, I can go back and fix it later, okay? And I need to add some stuff down here that says like, oh, if that happened to be true, then we need to do some stuff. But we'll get to that. Let's do the one where we get the players move. Okay, because that's what the whole game is. That's the fun part. That's where you actually get stuff where we can test it and start moving around and start figuring out what our errors are. So let's get the player move. Okay, I'm going to say... we're going to call it spot. I used the word spot earlier. That's fine to me. Spot equals input. Choose a spot. And now this is going to be really ugly. Okay, the way I'm going to do this sucks. And I know it sucks. So we'll go back to make it pretty later. But I'm going to say, hey, these are called 0, 1, 2, 3, 4, 5, 6, 7, 8. Just tell me that number. I know the users aren't going to like that because they're not going to be used to thinking as 0 first or whatever. They're going to want to say something like row and column or to just click on one. And I understand. We'll get that on a second draft. But I want to get something that works. Okay, 0, can't type, through 8. And that's going to say, if you want the top right, then you put 2. If you want the bottom right, you put 8 or whatever. Okay. And here's the deal. Let's say we make this function and it's great. And we decide to go back and make this prettier and give them the row and column version or something like that. That's just in this little function. The function does its job, and it doesn't bother anybody, and all the other code in the program is the same, okay? When you make this stuff separated into little modules, you might call it, then we can change stuff in here, and it doesn't affect the rest. We don't have to worry about, oh, if I make this different, then I got to fix this and this and this and that. No, the getPlayerMove function is its own little world, and it does its own little job, and the other ones, it's none of their business, okay? So when we change this later, which we will, it's going to be easier than it sounds. So let's say spot is input. Oh, by the way, it's probably going to need an int because it's a number that we're going to use. We're going to say, remember up here when we were calling each blank or whatever, X or O, each spot by putting that index right after board. We're going to use that here. We're going to say board spot equals X if it's the X turn, like if they say 0 and we want to make the top left an X, but if it's the O turn, we want to turn it into an O. So I can't put X and I can't put O, right? I got to put something general. So I'm going to say player, because whoever's turn it is, that's what it's going to put in that thing. And that means I'm going to need to put player right here because it's going to be a parameter. It's going to be sent to it. When it runs the function, it's going to tell it, okay, it's X's turn or it's O's turn, whoever, you know. So that's going to be getting the spot, filling it in. But if you remember, we had another goal, which is to test whether it's good. So we have to say, if the spot's empty, then you can put it in there. If not, we don't want to overwrite it. We don't want to say, hey, the top right was X, but O chose top right, so we're going to throw out the X and put an O in there. That's not the game. We got to avoid that. So we want to say, like, if they say one that's already taken, we want to tell them. And I don't know if you remember this, but we had a couple examples in quarter 1 of the while loop used for that. We say while their answer is bad, keep asking. And then while it's good, we're done, you know? So we're going to say while board spot is not blank, we're going to keep asking. And the way to do not equal is exclamation equal. While it's not blank, we're going to ask again, and we're going to just copy this line. I already hate it. I don't want to copy lines, so maybe there's a more efficient way to avoid that, but you get the idea. And we should probably tell them why, you know. We should probably say that spot is taken, and then choose another. But then if we're done with this, if this doesn't get triggered, or if it gets triggered and then they finally choose a good one, then we finally turn it into that player. So let's hit run, and I think it's going to give us the cool stuff. Okay, choose a spot. I'm going to say 0, which is the top left. And guess what? I forgot to take off the break. So it was only doing one turn. Now let's do it again. 0. Now that's an X. Now let's say O is going to say the middle, and that's 4. Okay. Now X is going to say bottom right, and then O is going to say blah, 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 And then X is going to say, and then O is going to say, hey, guess what? We didn't check to see if they win, right? That's the part we got to figure out. This, however, is pretty good, right? This is tic-tac-toe. This is X gets a turn, O gets a turn. X gets a turn, O gets a turn. This is the basics that we need, and we just need to fill in stuff. You don't have to wait until you're done in order to hit run. You want to hit run as often as you can, especially when you're testing like a single function. You don't need all the other ones. You just put pass in the other ones or whatever, or don't even call them up, and then we'll get going one step at a time. Okay, so let's say I want to add in a little blank line so they're not all squished together, and I can find a cool place to do that, but let's just say right here, print blank line, beautiful. That looks nicer, right? Okay. And if you notice, we can overwrite spaces that are already taken. Like if I say 3, never mind. I don't know what I'm talking about. That part's filled in. The only part that's not filled in is checking for the win. So let's say, I was gonna move that up a little bit. Okay. Let's say we want to check this. Now, here's the deal. I'm going to do the ugliest, silliest, most ridiculous way, which is to just check each one. Okay? In tic-tac-toe, there are 8 ways to win. There's 3 rows, 3 columns, and 2 diagonals. So there is a much better, cooler, more elegant way to use 4 loops and check all the horizontals at once and check all the verticals at once. And the diagonals, I haven't thought about it, but I bet there's a cool way because the indexes are all even numbers. We'll figure it out. But to get something going, to get our thing started, I'm going to use the most brute force method, which is just like check the top row, check the middle row, check the bottom row, check the verticals, check, and it doesn't have to be beautiful, but it's going to get us working, and then we'll go back later and make it nice. Just like the input, this sucks, but we'll go back later. It still works. And you want to have these modular pieces, doing their jobs and then doing their jobs better. So to check for the top row, we're going to say board 0, board 1, board 2 equals sometimes we need to check for X, and sometimes we need to check for O, and I don't want to make them separate, so I'm just going to say the word player again, just like we did up here. I'm going to put these in parentheses. I don't know if it matters. Let's do it. What the heck? And if this equals this, meaning like if the top row is XXX or the top row is OOO, then we're going to say true, meaning somebody wins. Okay, and now, like I said, it's the ugliest thing in the world, but I'm going to copy this. And I'm going to at least label it for logic's sake, but later we'll make them something cool. And, overcome my distaste for this. But we got 0, 1, 2. The second row is 3, 4, 5. The third row is 6, 7, 8. So this is checking like, hey, is the third row XXX or OOO? Great. Is the middle row that? Blah, blah, blah. And now we can actually look at this to figure out what the numbers are. We can say, oh, the left horizontal is 036. And the middle horizontal is 147. Again, I know this is ugly. And then the third one is 258. And then the diagonals are going to be 048 and 642. Like I said, they're all even numbers, so I bet there's some math trick you can use to check them in a more elegant way than just literally listing all the guys. That's kind of annoying. So we need to tell it which player, because it might be checking for X and it might be checking for O. By the way, another way we could optimize this is by saying we don't need to really check every one every time. If somebody puts it in the bottom right, then we only need to check the right column and the bottom row and then the one diagonal. We don't need to check the middle row or the middle column or the other diagonal. We can probably only check some of them some of the time. We also, by the way, don't need to check any on the first 4 turns because nobody can ever win on the first 4 turns. So there's a lot of optimization, but that's fine. The computer can do this in a couple milliseconds. It's not going to be overworked too badly. The last thing we need to do, by the way, is tell it what happens if somebody wins, or tell it what happens if it's full, because we've told it, hey, we're going to check and we're going to say true, but we've never said what that means. We've never said that, like, oh, if somebody wins, then we're going to tell them they win and kick us out of the loop and all of that. So let's do those real quick, okay? If somebody wins, we need to tell it which player. Then we want to show the board one more time to just say, hey, here's the final, situation. And then we're going to say game over. Somebody wins, but we don't know if we're going to say X wins or O wins. We're going to say player wins, right? And then we're going to say the most important word in the whole thing, which is break, because if they win, the game's over. We got to get out of the loop. We don't want to say another turn after we said somebody win. Okay. And then the same thing here. Check for full. If it's full, we want to show the board one more time just for the record. And then we're going to tell them what's the situation. And then we're going to, again, break. Okay. So I think this is the whole thing. Let's see what happens. Choose spot 0, 1, 2, 3, 4. Let's say 8. Now X is going to win. X is going to get this diagonal of boom, 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 which means they're going to hit 6. Game over. X wins. Great. Let's test for O winning. Okay, let's say O is going to get the right column. So O is going to go 2, and then 5, and then this is, oh, we need to say whose turn it is. You know what I mean? Like, we want to make a line that says it's X's turn or it's O's turn or whatever. Player plus turn, because it's hard to keep track. X's turn, I can't get that right. X's turn 0, O's turn 2. Now O's gonna win by choosing this guy, which is 8. O wins. Okay, now we could test the board full, but that's gonna take a minute. This is using a lot of the stuff we've seen, making a couple functions, using a little bit of input, a little bit of loops, a little bit of if, and putting it all together, which is what we're gonna be doing in quarter 2. The other thing we're going to be doing in quarter 2 is this stuff where you have a list or you have some other kind of data structure. We'll see a few others where you try to go to a certain spot in the list or test a couple ones in the list or add things to the list or take that blank and fill into the next or whatever. Now this, again, this is really ugly. We'll change this to make it more elegant. This is really ugly. We'll change this to make it more user-friendly. This is really not optimized. We might make it check only on turns where it's possible to win and only on lines where it's possible to win, but it's fine, okay? This works, and this is okay. We want to have something to start with rather than theorizing forever before we do a line of code at all. We can make this prettier and faster and better now that we've got it Whereas if we had planned forever to say, how could this be perfect? We wouldn't have anything at all. Thanks.